What's that? So, keeping that in mind, we talked yesterday how you can't have a coefficient. So we take a standard form, we're working into vertex form. The other, maybe more popular way we use completing the square in Algebra 2 is with figuring out the center and the radius of a circle. So, for example, if I have 2x squared plus 2y squared minus 8x plus 6y equals 10. That's a circle. And they would probably indicate to you that that's a circle. You know, find the center and the radius of this circle. It's actually coming up on this weekend's homework as well. Or maybe like Tuesday night. But it's coming up in the next test that you're doing. We need to, first and foremost, you cannot have the coefficients on the x squared and y squared. So you need to divide everything by 2. So that's going to make x squared plus y squared minus 4x plus 3y equal to 5. And then I'm sort of going to rearrange so that my two x terms are at least next to each other. So x squared minus 4x, and then plus y squared plus 3y equals 5. And then we complete the square on the x's. So what's the magic number? 4. Because you take half of that, which is negative 2, and square it, that gives you 4. So you add 4 to the left, add 4 to the right. That now made this factorable into x minus 2 times x minus 2, aka x minus 2 squared. Whatever half that middle term was, that negative 4, that's what the factored number is. The second one we're going to have to probably use our calculators with, because when you take half of 3, you get 1.5. And 1.5 squared is 2.25. So not a great number. So I'm going to have to, that's okay, I'm going to add 2.25. And now this has become factorable into, and like I just said before, it's always whatever half of that middle term was. So that middle term was 3, so it would be y plus 1.5 squared is what that factors into. And that all equals 11.25. So what is our center, Alexis? 2 comma negative 1.5 is our center. And our radius is going to be the square root of 11.25, which hopefully would end up being a nice number, but we'll just leave it like that. Okay? So in both of these cases, I kind of illustrated how you can't have a coefficient. So we had to, in this case, we had to factor out the 2, and then in this case, we just divided everything by 2. But that's where completing the square is most prominent. Okay? All right, so let me run back to this real quick. Keep your sheet of paper out because we'll need it. But so this focus and directrix question that was on the last night's homework, it was a multiple choice on last night's homework, so you could kind of just figure it out from there. Here it's not a multiple choice. That's why I told you that give me any focus directrix. But this is not uncommon, and this is also coming up on this weekend's homework, where they give you the quadratic equation, but they do not, yes, but they do not, this is important though, I don't know if you want to miss this. You do not get the equation in the form that you're used to. This is the format that we talk about on a daily basis, right? HK? But it's not in y equals format. So we actually need to get it into y equals format. So the first thing I would do is divide the 4 over. And that's going to make it 1/4 x plus 2 squared. And then we're going to add 6 over. So tell me, Anthony, what is the vertex now that I see it in the right format? Negative 2, 6. Good. And like any focus directrix question, we need to plot as much as we can. That's the vertex. So, is our parabola opening up or down, Riley? Nope. A is a positive 1/4, so it's opening up. Okay? So, and this is where I said, give me any focus directrix, because in the multiple choice, you were able to process of elimination, but the fact of the matter is your focus has to be the same number of units above here as your directrix is below. So one combination could have been going up 1 point, so that would have been at -2.7, paired with a directrix at y equals 1 unit below would have been at y equals 5. Or you could go 2 units above for the focus, so that would have been -2.8, and then your directrix would have had to have been 2 units below, that would have been at y equals 4. You could have gone 3 units above for the focus, so -2.9, and 3 units below for the directrix, 1, 2, 3, would have been at y equals 3. Do we get the point? As long as they're equidistant on either side, and in the solutions in the homework, 3 of the 4 of them couldn't have been. Okay? They have to be, the focus has to be up some and the directrix down some, or vice versa, but they have to be equidistant from the vertex. So I will allow any one of those. Okay? On this next one, the mean score on a recent SAT test was 1080, normally distributed, so immediately we should be doing something like that. The standard deviation of 152 we'll hold on to. What is the minimum score she can get to be in the top 10%? So this is like a percentile question. We want the top 10%, which means, what percentage is this? If this is the top 10%, what's this? The bottom 90%. So essentially, this is a norm CDF question. The lower end of your interval is -999. The positive end of your interval is what we don't know, right? We don't know what score that's going to be at. Our mean is 1080, and our standard deviation is 152. Okay? Again, this was a multiple choice, so we could have taken our 4 answers and plugged them in and kind of guessed and checked. But that's what I'm going to have you do here anyway. So just guess a score, okay? Given that a standard deviation is 152, one standard deviation above is 1080 plus 152, which would be 1232. That's not high enough. And then one more standard deviation above would be 1384, which is going to be too much. So 1232 is too little, and 1384 is too much, because 2 standard deviations brings you to the 95th percentile, right? Actually 97.5. There's only 2.5% above that, so that's too high. So we would just kind of guess and check in between here until we got this equal to .90, or as close as we could. So if I just guessed like 1300 to start, and I ran a norm CDF from -999 to 1300 with a 1080 and a 152, that's the 93rd percentile. She only needs to be in the 90th, so that was a little too high, because that gave me the 93rd percentile. So I'd go down a little bit from there. So if I go back up and try it, that was 1080. Maybe I would try 1075. Oh no, 1080 was the average. I did 1300, so maybe I try a score of 1295 and see what that gives me. Okay, that's lower, but not by much. So I just went down to 12, and I just tried 1300. That gave me .92.
I kept dividing the margin of error in A, or subtracting the day, till I got something close to 90.
Okay, well, let's see how close maybe that's legit. Let's see here. I'm going to go from 1295, since that didn't really drop much. They both rounded to .92. I'm going to go down to like 12 75 and see what that does. That's pretty good. Okay? So whatever number you picked, that just gave me the .90. So I would take that, whatever number you picked, I'm just going to check. It's got to be in that ballpark. And I'll check, and if it's a .90, you'll get it. Okay? So sort of a guess and check. It is obviously more difficult when you don't have the options in front of you. This is a recursive formula that's taking the previous term and doing what to it? Come on. Adding. So is it arithmetic or geometric? If you're adding, arithmetic, right? So the arithmetic formula from our reference sheet, arithmetic sequence right there, a sub n, you can go ahead, Tyler, equals a sub 1 times r to the n minus 1. So your a sub n is your nth term. What was our first term? 18.5. What was our, did I just do the wrong one? I sure did. A sub 1 plus, I copied the wrong one down, because we don't have an r. That was silly. Okay, 18.5 plus n minus 1 times, what was our d? 1.4. That was our common difference. So that's good enough. If you wanted to distribute that 1.4 and then combine like terms, so 18.5 minus 1.4.
I started from A0.
Well, the formula uses a sub 1. So they gave us that.
That's kind of what my wrote for my formula.
Yours ended up looking like that?
Yeah.
Good. And you got it. Okay? So that's that. And then this last one, the log question. So given that function, find the product of the x and y's. Now, you can graph this on your calculator, right? Do you know how? How would you type that in? Alright, so Jake knows in the math menu, you can get the log base, and then you can type that exactly in 2, and then x plus 9.
3.
Oh, log base 3. Was it 2 on the homework? That's why I screwed that up. Log base 3. Okay. So let me go back to a standard graph. So I'll do zoom 6. And it wants the product of your x-intercept and y-intercept. So for your x-intercept, how do you find your x-intercept? How would I find that here? Maybe I can't, I can get in the ballpark, but it doesn't look like it's a whole number, does it? How do you algebraically find the x-intercept? It's on our flashcards. What's that? No, I'm going to talk about that though. Set y equal to 0. To find the x-intercept, you set y equal to 0. So that would be 0 equals log base 3 of x plus 9. And then to solve that equation, we have to to solve a log equation, you have to translate it. 3 raised to the 0 power equals x plus 9. So that's 1 equals x plus 9. Subtract 9 from both sides, and the x-intercept is negative 8. How do you find a y-intercept? Set x equal to 0. So this will be y equals log base 3 of 0 plus 9. Y equals log base 3 of 9. And then 3 to what power gives you 9? Like, right? 3 to the y gives you 9. What's y? 2. So the product of those is negative 16. Yes? Okay. Now if you could look at your graph and pull the x-intercept and pull the y-intercept, it didn't look like it was a whole number to me, but apparently it is. If you could pull those, fine. We also, and this is going to bring me to my next point, so that was the end of the quiz, but I added some flashcards, and part of my inspiration for that was when I came across some of those questions. Oh yeah, the change of base formula, right? So the change of base formula, if you ever have log base B of A, and you want to type it into your calculator. Now, Jake, there is obviously a place to do it under your math menu, but you should also know that it's the same as the log of A divided by the log of the base, okay? And then I thought about some parent graphs that you should know what they look like. So if the front of the flashcard says exponential parent graph, Jake, pay attention because these are going to be on Monday's flashcard quiz, then we go upward, right? Exponential parent graph, it's exponential increasing, and you have to know that critical point. The equation is y equals b to the x, and this is what it looks like, and you have to label that critical point at 0, 1.
You're going to put this on the computer.
Yes. Now, there also is an asymptote at the x-axis, so make sure this does not cross that. For the log parent graph, which is its inverse, it's just kind of flipped over. So your x-axis, which was an asymptote, is now an asymptote at the y-axis. Your point 0, 1 is now 1, 0, and there's the parent graph equation. So the back of your card is going to need to require the formula of the parent graph and the picture with 0, 1 labeled. The formula and the picture with 1, 0 labeled. Okay? Also a parent graph for a radical function, which kind of has a dead end at 0, 0, and then just goes upward like that. That's a radical function. So I thought, oh, those parent graphs would be important, because on this last one, this was the parent graph shifted to the left 9 units, yes? Right? And so the parent graph, the log parent graph, which usually is like here, got shifted left 9 units. So the asymptote that used to be at y equals, or x equals 0, got shifted left 9 units as well. So the new asymptote is over here. Good? Okay. And then Pythagorean identity. There's a question that comes up. I don't know if it's on tonight's homework, but the Pythagorean identity is that the sine squared of x plus the cosine squared of x equals 1. So if you, not the Pythagorean theorem, Pythagorean identity. So in other words, if it was sine squared of 81, add the cosine squared of 81 and it should give you 1. These have to be matching numbers or matching expressions. Okay? And then average rate of change should be an easy one, but I thought, well, let's put it on there. Just knowing that average rate of change is slope, and then complete your slope formula. So those 6 new flashcards are now going to be in the mix for Monday. We're actually not going to do a flashcard quiz today, so on your way out, put that back on the table. And you all need a green book, okay? We've already done the first 3 tests out of the green book.
We got the 6th test.
We did, no. We did 6 tests, 3 of which are the first 3 in this book. Okay? So, this weekend's homework is June 2016. You can have a seat, I'm going to bring them to you. June 2016, and the first set of numbers again, the same 1 through 10, 25 through 28, okay?
Separate sheet or in the box?
Separate sheet. Absolutely a separate sheet. There's not enough room in the book. Okay? The solutions are online, but not my work. So that's a little shift. We're kind of upping the ante. Like I said, I'm averaging the 5 tests that you took this week. That's 10th grade. And I'm going to average the 4 tests from next week. But the solutions, I'm slowly kind of making you more independent, hopefully. So I have the solutions, all the multiple choice answers, and the answers on the short answer, but not the work. So, again, you're going to have to dig a little bit deeper, and hopefully you've already enhanced your knowledge quite a bit. And I'll be in Tuesday morning if you have questions. Okay? Okay. No, I won't, just because there's so many people out. All right, thank you. If ever you need something, Riley, and you can't get it, what can you do?
I tried it last night.
You sent a remind message though last night. I had kids do that, and I just snapped them a picture and sent it to them.
I always forget about that.
Try to remember that.
Like
You have 20, and if I can't do it, then that's fine, but.
I tried it last night, and then I thought maybe like they would fix it.
I'm sorry.
They would fix it, so so then I tried it again.
Yeah.
My second period,
Yeah.
and it's still...
It's been off and on. It's kinda like, depending on what second you hit process, sometimes it works and sometimes... Crazy. All right, have a great weekend.
You too.
Thank you.
Same, Mr. Wyman?
I'm going to my parents' little cottage, but it's
Hey,
gonna be
don't forget
rainy,
the-
so I said to my mom,
Mr.
what's better
Wyman?
than being stuck in a 700-foot cabin with your
Yeah.
family all weekend?
Excuse me, how about you get the black person giving him a party?
Yeah.
Next time I'm taking it for the rest
If
of
I
the
get a
day.
chance.
It's been enough is
Okay.
enough is enough. Oops.
Okay.
Don't hurt me with these. All right, have a good weekend.
Where's the guy?
It's north of Utica, Cayuta Lake it's called, so it's like just southern Adirondack.
Is it right on the lake?
Yep,
Oh, very
yeah,
cool.
yeah, so, we grew up going to lakes, so,
Yeah, we're going out to, Stockton, my in-laws have
Oh,
a,
beautiful.
Cottage.
I've never been there, but I've heard it's beautiful.
Yeah.
Yeah.
All right.
We'll have fun. I hope that we get some bit of sunshine.
The rain says no.
I know. Not what I was hoping for.
Kind of like misting out right now.
Mhm.
Here's the recording.
Oh, I am?
Yeah.
Thank you.